Okay, this is exam 3, physics 202. What happens to the brightness of bulb A when you close this switch? When you close the switch, bulb B will go out and bulb A will burn brighter than before. Which of these rules for resistors is not correct? Resistors in series must have the same current. All right, that is correct. Resistors in series must have the same voltage. That is not correct. The voltage across is equal to the sum. And this one is also a true statement, so the only one that's not correct is B. So be careful with the wording on these, but it's a good advice actually for standardized exams that you're read very carefully. So you might have or you might have not noticed this not, and you would have come up with 2, 3, and 4, but then it's not an option. So you should always go back and reread the question again, okay? Which of these statements is true? Magnets have only a north or south pole. That's not true. That would be a monopole. North poles of a magnet attract. That's not true. And wood is ferromagnetic. Okay, so E is the right answer. Another good pointer on standardized tests is that, sometimes all or none is the answer, in fact, and, students often think that that's not the case. All right, what is the unknown current? Well, it might be better to redraw this with 4 amps going in, 2 going in, 8 going in. That means I'm going to have some current going out, 8 plus 4 plus 2, which is 14 amps going out. Which of these statements about a household circuit is true? It's a series circuit. They operate at the same current, operate at the same voltage, and it's a parallel circuit. Total current increases. That's true. That's why we have our circuit breakers. And 4 is also correct. So 3 and 4. What happens when you to the voltage of each electrical device when you add more appliances? Well, the voltage stays the same. That's why they're laid out in parallel. Current has SI units of coulombs per second. Which of these about a magnetic force is true? It's parallel to the magnetic field? No, they're always perpendicular or orthogonal. It's opposite to the electric force? That's no, actually. Sometimes, but not necessarily. In fact, we use electric forces and magnetic forces to direct beams of charged particles, and the magnetic force can change the energy of the particle. All right. We talked about this a little bit, and if you go back to thinking about, actually, I might change this, but it's a centripetal force, so it does not change the energy of the particle. So I'll probably change this. So number 8 will be different from this, because we haven't got the centripetal forces yet. Which resistor is the current the greatest? Well, notice that this goes to 1, so I have 3 ohms in the bottom and 4 ohms in the top. 2 plus 2 is 4. And it's going to split up between these two. I'll have a small current go up here and a bigger current go up here. So looks like R5 has the biggest current. You wish to measure voltage across a resistor. You want to connect the measuring device in parallel. That's your voltmeter. If I switch S closed, what happens to the current through R1? If I close this switch, that means that my total resistance is going to decrease. So the current is going to increase because my resistance decreases. The equivalent of this decreases. The overall equivalent is also going to decrease, so the current will increase. 2 pieces of wire have the same length. The diameter of wire A is twice that of wire B. So this is wire A. This is wire B. Wire A then, because it just has more metal to push stuff through, is going to have a lower resistance. So I can get rid of this one, and this one. And because the diameter is twice, remember R is rho L over pi diameter squared, or pi R squared. Then it's going to be an inverse square, so C is the right answer. 1/2 squared is 1/4. What is the bigger resistance? Well, the bigger resistance is the one that resists the flow of electricity the most, and that's going to be the light bulb. That's why it has less power. And indeed, we really do want you all to succeed, and that's our job here at Nichols. That's our job in this department, and so we want you to succeed in your chosen paths. Now let's get on to these. Now if you can look at this, you could probably work this out without drawing much, but I'm going to work it out the long way. That's 1 ohm. I have 2, 4, and 4 ohms. And then I have 8 and 8 ohms. 2, 4, and 4. 1 over 2 plus 1 over 4 plus 1 over 4. That's 1 over 1, which is 1. And then 1 over 8 plus 1 over 8, that's 1 over 2 eighths, which is 1 over a quarter, which is 4. So this circuit goes down to a 1, and a 4 ohm resistor in series. The equivalent then is going to be 6 ohms. And if I have 6 ohms here with 12 volts here, that means I have a current equal to 12 over 6, V over R, which is 2 amps. So my current here is also going to be 2 amps. I'll do my currents in red. So this is 2 amps, 2 amps, 2 amps, and then my voltages, I'll do here in orange. This is going to be 2 volts, 2 volts, 8 volts. 8 plus 2 plus 2 is 4. 8 plus 2 plus 2 is 12. So now I can go back up here. I have now 2 volts here. I have 2 volts, 2 volts, 2 volts, and I have 8 volts, 8 volts. And so this is going to be 8 volts. Just sort of transferring these over, 2 volts and 2 volts and 2 volts. So now I'm almost done. Notice in these two, they're equal resistors, so they're going to split that voltage the same, 1 volt and 1 volt. And then between these two, I have 8 volts. But the equivalent of this is 8 ohms. That means I'm going to have 8 over 8, or 1 amp of current. 1 amp across 5 ohms is 5 volts, and 1 amp across 3 ohms is 3 volts. So that gives me all of my voltages. I have 2 volts, 2, 1, 1, R5 is 2, 5, 3, and 8. And then I can go and do the currents. I have 2 amps. I is equal to V over R. So here I have 2 over 2, which is 1. Here I have 1 over 2, which is 0.5 and 0.5. And here I have 2 over 4, which is 0.5. So I have 1 amp, 0.5 amps, 0.5 amps. And notice 1 plus 0.5 plus 0.5 is 2 amps, which is what's going in. That's good. And now R6 and 7 is 1 amp and 1 amp. I've already calculated that. That means I must have also 1 amp going through R8, because it has to add up to equal to 2. And that's the answer. All right, here, let's just pick some directions. Okay, let's see here. I'm going to choose this first one up for no reason. It's just I've worked this before, so I'm just going to use what I used before. Up, down, up. No particular reason for those currents, and we'll factor and find that some of them are wrong. I'm going to do the left loop, the right loop, and then the junction rule. I need 3 equations. So left loop, I will start in this direction, going in that direction. So that's going to be 4 plus 1 I1 plus 2I2 equals 0. And then I'll do the left loop, or the right loop rather. I'm going to start here and go in this direction. That's 2 plus 2I2 plus I3, that's plus 1 I3 equals 0. And now I'm going to do the junction rule. I'll do it down here. I2 is in, I1 and 3 are out. All right, so look what I got here. I can solve this equation for I1, this equation for I3. Then I'll have I1 and I3 both in terms of I2, or I2. And I'll get this. I'll get I1 equals negative 4 minus 2I2. And I3 equals minus 2 minus 2I2. And now I plug these both into the junction rule. So I get I2 equals minus 4 minus 2I2 minus plus I3, which is minus 2 minus 2I2. And then we can solve that, and we find that I2 is equal to minus 6/5 amp. I'll let you do that on your own, but I'm going to put up here 6/5 amp, and I chose it down. That means it's up. Now I can put then up here, plugging in minus 6/5 for I2, and for I1 then, I get minus 8/5. So you can do it decimal form if you want. and doing a similar thing here, putting in minus 6/5 here, I get 4 over 10, I get plus 2/5. So I1 is 8/5. It's negative, so it should be down. That's opposite the direction. And then I3 is 2/5, or 0.4. Or excuse me, 2/5. And it's positive, so it should be up. A few sentences describe what GFCI does, how it works, and what it protects people from. All right, turns off. You don't want this in complete sentences, preferably. If IN exceeds I out, and it does this, it has a very sensitive ammeter that checks that current constantly in time, and then it protects people from faulty devices in dangerous conditions, which are usually in wet conditions, bathrooms, outside, etc. Looking for something along those lines. All right, here I want to know the force. This was just simple cross product. That's all I was looking for. I have 2 coulombs times V, which is 3I minus 4K, crossed with 2I minus 5J. I do my foil, that's 2 first. I don't have to do that because that's I cross I, which is 0. Outer is 15 I cross J. I'm sorry, this should be negative right here. So it's negative 15 I cross J. Inner, minus 8 K cross I. What's that? FOI. And then last is minus 4. That's plus 20 K cross J. All right, doing my right-hand rule to figure out I cross J, K cross I, and K cross J. I find that this is minus 30 times I cross J is positive K, minus 16 K cross I. What is K cross I here? I have I, J, K. K cross I is positive J, plus 20. K cross J is negative I. So writing this out, I get negative 20I minus 16J minus 30K. All right, here you first need to find the resistance, is V over I, and that resistance is 0.07 ohms, and then calculate the resistivity, which is RA over L. That's from our resistance equation, and this turns out to be 5.495 times 10 to the minus 8. This is in, what's it, ohm meters, I think? Yeah, ohm meters. And just go through and pick out tungsten as the right answer. Draw the direction of the force. Well, it's right-hand rule, and your forces are in this direction, and out of the page. And then there's a problem on the back page. How long does it take for this to fully charge? You need to find the time constant first. That's going to be 2 times 1, which is 2 seconds. And then the time to charge is going to be 10 times that, which is 20 seconds. Sketch a plot of the charge versus time as it charges. Charge versus time. It's an exponential growth function. It goes up to a maximum value of Q equals CV, which in this case is 12 times 1, or 12 microcoulombs. You don't have to get that value, but you'll use it in just a second. And what else did I say? Indicate the value, show the approximate position of tau. Tau is approximately right here. And then the time to fully charge is, about 10 times that down there. C, I want to know the charge at 1 second. That's going to be 12 microcoulombs. I've already shown you that C times V times 1 minus e to the minus 1 over 2 seconds. That's my time constant, which I found up here. And this has a value equal to 4.7 microcoulombs. And then I also want you to find what is the time when t is equal to 5 seconds, and since you know this is 4.7, you know it has to be close to 1 second, so that should be a good check for you. Using the same equation, except now we're looking for t. Just want to make sure that you can do this. This works out to be the natural log of minus 5 over 12 plus 1 equals the natural log of e to the minus t over 2. This cancels, and I find that t solving this is 1.08 seconds, which is good because that's sort of what it should be. It should be a little bit longer than this time. There's your multiple choice answers. That's the end.